Okay, wonderful. So, first of all, belated happy Independence Day. It was yesterday. I hope you guys had some jalebis. That's what used to be our motivation when I was our age. I mean, maybe little younger than you guys. So, every 15th August, we'll go to school not to do anything else but to eat jalebis. Alright. So, today's class is going to be a pretty loaded class. Loaded when I say there are a lot of interesting concepts that we'll talk about, and I will teach you guys something that I would not myself agree to if I look at it with a very, what you call, very simplistic way, with a very simplistic view. So let's get started. The first thing that we will learn is called the Squeeze Theorem or the Sandwich Theorem. Who all has heard about it, and tell me what is your understanding of it? Yep, go ahead, Chris.
I think it's if you have like two separate limits, and like you're trying to find a limit that like lies between them. So like you have a limit of 4, like limit as x which is 4, and limit as x which is 6. If they both approach the same number, then any limit in between those will also approach the same value.
Okay, that's a good explanation. Nancy, how would you judge you first time? So you would agree to whatever Chris said, or whatever I will say. Okay. Alright, Ananya, how would you do?
I have heard of it.
But we briefly touched upon that in the last class. I know I rushed through it in the pre-calculus class, right? We briefly touched we briefly touched upon it. Okay, so as Chris mentioned, this is more of a very intuitive form of correlation that we draw from a set of functions. And are you able to see the full screen? Okay, Chris, Vidansi, and Ananya. Anya, is the video working or some issue? No? Alright, fine. That's okay. For Ananya, I have a lot of flexibility, okay? Ananya comes to in-person class most of the times. I mean, not for this one, but the other classes that she does with me. So, I can give her that flexibility of not running her video on. Okay? Alright, that was a bad joke. Let's move on. So, basically, what the Squeeze Theorem says, like what Chris explained, it says that if you have one function like this, another function like this, and the third function is squeezed, the graph of the third function is squeezed between these, or is sandwiched between the two functions. This is function A, this is function B, and this is function C. So function C is squeezed between function A and function B. As long as these two functions define the boundary for the function in between, this function's limit will be equal to the limit of the other two functions if they are approaching the same value. Yeah, that's what you should Chris, right? Or in practical terms, what it means is, let's think about a scenario like let me put a hypothetical situation where I have 3 kids here, Vedansi, Chris, and Ananya. Okay? And again, please don't get offended if I say something about you guys without your consent. Don't worry about it. I'm saying all of you here, okay? Let me put it this way. I know Ananya just started high school. You guys probably are a little bit into high school already. So that's what I'm saying. Ananya is the youngest of 3, okay? Ananya, let's say this is Vedansi, this is Chris. Okay? I'm saying Ananya is younger than Vedansi, and Vedansi is younger than Chris. Just make it up, okay? Don't go to the actuals, okay? In this scenario, I can represent that with this relationship. Ananya is less than equal to Vedanshi, Vedanshi is less than equal to Chris. Okay? So here, if I am thinking of Vedanshi as a function, this function is squeezed between this function and this function. So age of Ananya is one function, age of Vedanshi is another function, and age of Chris is another function. So here, age of Ananya is one function, and age of Chris is another function, and age of Vedanshi is a function that is in between the two functions. So if I say Ananya is 12 years old, and I am saying Chris is also 12 years old, going by this definition or this proposition that you see right now, you have no other choice but Vedanshi will be 12 years old as well. This is where the outcome of this function or the limit of this function is dictated by the limit of the function that is squeezing this one. That is the basic premise of the squeeze function or the sandwich function. Okay. And when we talk about limits, none of the definition or understanding of limits change. None of the propositions that we are aware of with respect to limits, continuity change. This is just another intuitive way of looking at things. And when we look at some examples for solving it, this will start making a little more sense to you guys. Are we okay so far? I hope nobody has heard with me calling out the age. Yeah? Yeah? Okay, I was not comparing you guys, I was just giving an example. Okay? So, my examples are like that jokes. Please excuse them if it at all sounds unreasonable or not. Okay? So, the only thing with the squeeze function or sandwich function that you need to keep in mind is, let's say this is one function f of x. This is another function g of x. And there is a third function, that poor guy is sandwiched between the two functions h of x. And this was my coordinate plane, let's say. So here, what is there to observe is that this function's output, not only the limit, okay, also the outputs are actually always above this. Okay? This function, the other one that is squeezing it from the bottom, that is all below this. I mean, if let's say this function goes like this is not a scenario of the sandwich function. Okay? So, if you guys have, I'm sure everybody has eaten sandwich. If you have seen the sandwich, let's say it's a paneer sandwich. Your paneer is never visible from outside. If you look at the bread from this side, you know there is a paneer but that is inside. If you are looking at the sandwich from this side, you know there is a bread that is visible to you and paneer is inside. So in the case here, if you are looking at it from top, this function that is squeezing it from the top is going to overpower this one or going to cover this one. Likewise, if you are looking at it from the bottom, you will see that all the output of this function is hiding it underneath. Okay. So if you see the function that is supposedly getting squeezed between the two functions, and if it is crossing and coming in between, it doesn't repeat the same scenario of squeeze function and doesn't work with the concept of squeeze function. Does it sound okay? No? Okay. So what I will do is, I will quickly share my screen because I have put some questions here and I simply want to avoid the wastage of time that I will do otherwise if I am trying to draw it all on the screen. Okay. So let me, are you able to see my screen? Yeah. Okay. So I will show you guys some examples and then we will try to relate to it. Okay, so that without me drawing it on the screen, at least you guys can Put your head around this one. Okay? Come on. So Ananya knows that there's some paranormal activity that happens in the class. Come on. Come on. I don't know why it is not listening to me. If it keeps being that way, I will have to switch to my manual mode. Okay. I hope this time was worth investing. Well, we should be able to save some time here. Stop. Yeah. Now look at this one. We will start with this problem. Can you guys see this graph on the screen?
Yeah.
See, this is the paranormal activity I was talking about. Okay. So, this question says you want to find the limit of who is doing this? How is that even happening? Guys, okay, not working. Let me stop sharing. Okay, can you guys leave this. I have to stop sharing, otherwise I'll end up struggling so much showing it to you guys. Okay. Alright. So let me, I have no other choice but to draw it on the screen and we'll try going as fast as we can. So I'm looking at the first problem. This says we want to find limit of x approaching 0 for x over sine of x. And the direct substitution method and other things are not working. I mean, this is a problem given, okay? Algebraic methods that we want to apply, that is not working. And this graph is like this. This is 1. This point is 1. And we have a discontinuity here. Yeah? So this is the function for which we are wanting to find out the limits for x approaching 0. And this is x over sine of x. Are you guys okay so far? Ananya, Nancy, Chris? Yeah? And the problem says that with all the algebraic method or whatever we have learned, this is not working. So we want to use the Squeeze Theorem. So it says to prove that the limit of x over sine of x is equal to 1, to prove that this is the value of this function for x approaching 0, somebody has used graph like this. And this one is f of x, this one is g of x, and this one is h of x. Where g of x is equal to e to the power x and h of x is equal to e to the power minus x. So this one is h of x, which is e to the power minus x, and this is g of x, which is e to the power x, and f of x is this one that we are trying to find the limit for. And we are trying to prove that f of x is equal to 1. So far okay?
If it's an exponential, wouldn't it have like asymptote?
That's what you're saying. So we have not drawn the asymptote right now.
Would there be an x asymptote as well?
I'm sorry, ma'am?
Would there be like a horizontal asymptote as well?
Yes, so there'll be. So let's not go to that side of thing right now. What we're trying to say is we have a function f of x for which we are trying to find the limits and trying to prove that is equal to this. This is between the two functions g of x and h of x. Okay? And somebody was trying to solve it. Harvey, somebody named Harvey suggested that we can use g of x and h of x in order to apply the Squeeze theorem. These two functions were used to apply the Squeeze theorem because regular algebraic method was not working. So now we have to make a judgment and say whether Harvey's suggestion was correct or not. And here are three options. One option says yes, Harvey or Harley, whoever it is, her suggestion was correct. Second was, no, the suggestion is incorrect because it is not true that the output of one of the function is always below function of x and the output of other function is always above the x value. And the third one is, no, Harvey's suggestion is incorrect because it is not true that the limit of a and b are matching. So, for this particular question, okay, while your point Vedasi is correct about the exponent function that we have asymptotes, let's not worry about that one for now. For solving this problem, this said that we are trying to find out the limits for this function and we are trying to prove that for x approaching 0 it is 1. Somebody took a punt at it and said, okay, fine, we can use g of x and h of x and apply the Squeeze theorem for solving it. Based on whatever you see here on the screen, let's say f of x is the one for which we are trying to find out the limits, that is in blue color, and somebody suggested to use this function h of x and which is the green one, and the other function g of x to apply the Squeeze theorem to find out the limits. We have to just assess and tell whether this approach was correct or not. If yes, why yes, if not, why not. Because we see that all are approaching one value of 1 when x is approaching 0. So that part is taken care. But is this approach correct or not is what we have to figure out. It's more about the application of the Squeeze theorem that we talk about. Chris, Sudansi, and Ananya. I want to hear your opinion on this one. What you think?
I think answer B is correct. Even though it results into the same option, since there would be an asymptote around 0, it wouldn't satisfy the Squeeze theorem.
Okay. What about Chris? What do you think? How about Ananya? What do you think?
I think so too.
Yeah. So it's very simple. As I was saying, again, I will not look at it with any intelligence. My simple go-to plan would be, if I am using Squeeze theorem, the two functions within which my target function is getting squeezed have to have a scenario if this is the function above. And for every value of x, this function has to have a higher value, but we see it going downward. So this is certainly not going to squeeze this function. Likewise, the other one, which is the green function, if this is also kind of trying to contain the boundary of this one, for any value of x, it is supposed to be either below or above. It cannot be on one quadrant it is below and one quadrant is above. Does it sound okay? If it sounds lame, let it be. Your simple thing would be that if I am going to use Squeeze function, I will use it only under the circumstances that if this function is getting squeezed by other two functions at the limit, if let's say this is my limit, okay, whether we have asymptote or we don't have asymptote, the one that is in the middle, this function for every value of x, the function of x has to be below the value for this guy, below or equal to, and it has to be above or equal to this. So let's say this was my function for which I was trying to find out the limit, and that is getting squeezed by this is g of x, and this is the one above this is h of x. Now you'll be able to see the correlation here. So f of x is greater than or equal to g of x, and this is less than or equal to h of x. For every value of x, that has to be a precondition. Does it sound okay or not okay? Let's look at one more problem and then we will look at something which is even more interesting. Okay, so now I will probably try not to read all the questions. Okay? I will only look at the key content of it so that we are able to solve it. We are able to solve it faster. So this is one function in red color. Other function is in blue color. Okay? And the third function is in a brown color. Okay? So this is g of x, this is f of x, and this is h of x. We had some constraint or problem in life which was not letting us find out the limit for f of x when x is approaching 0. Okay. In order to solve this, somebody called Brenda suggested to use Squeeze theorem, and one of the Squeeze theorem, one of the theorem that is one of the function that is squeezing it is g of x equal to sine of x, and other one that is squeezing it is h of x, which is equal to sec of x. So somebody is trying to solve or find the limit for f of x, the blue one, using h of x and g of x, which is sine of x and sec of x respectively. The question is, did Brenda use the right technique to find the limit for f of x? And if she did, choose from the three options. First is, yes, Brenda's suggestion seems to be correct. Second option is, no, Brenda's suggestion is incorrect because it is not true that one function is always below function f and one function is always above it for x value near 0. And third one is, no, Brenda's suggestion is incorrect because it is not true that the limit of g and h are both equal to 1. So which option you guys are leaning towards? Last one. So as soon as you see this kind of scenario, okay, so Chris and Ananya, you guys agree to what Vedasi said? Yeah?
Yeah.
As soon as you see this scenario, okay, I will keep my intelligence aside. Simple thing is, this is not even a classic example of a squeeze theorem, okay? Because we don't see any value for x where limit for this and this are approaching. Okay? The same value. As soon as we find them disconnected, this is certainly not an example of Squeeze theorem. So then, to make ourselves align to the narrative of Squeeze theorem, we'll pick the option that is most relevant. So you guys picked up the third option, which I'm okay with. Now, this is the Squeeze theorem, and again, I don't want to muddy the water more because I can keep on giving example after example after example, and that will not add much value. So I want to do something which is a little different. But are you guys comfortable with what is Squeeze theorem and the application part of it? Vedansi, Ananya? Yeah? Okay. So I need to switch gear now. So whenever you guys come across squeeze theorem, it's just a method to find out the limit of a function which is squeezed between two functions or sandwiched between two functions. Your only lookout would be the limit that you are trying to find for. For that limit, all the functions should be converging to a point, that is 1, and the function above this and function below the function that is getting squeezed have every value of x such that the value of the function is above and below that function that we are trying to squeeze, right? Let's say if this function is getting squeezed by this and this, for every value of x, this function has to have a higher value. F of x has to be a higher value than this one. Likewise, for every value of x, this guy is supposed to have the value of the function below the function that it is trying to squeeze, below or equal to. So it has to meet this criteria of f of x less than one other function and greater than or equal to other function. Yeah. If you see any crisscross happening, give it up. Yeah. All right. So let's look at some interesting problem, and we will try to find out limit of something. By exploiting lot of concepts that we have learned before. So I want to find out the value of, or I want to rather prove the value of sine of theta over theta for limit theta approaching 0 equal to 1. We want to find, or we want to prove that limit of sine theta over theta equal to 1 when theta is approaching 0. We want to prove this one, sine theta by theta equal to 1 when theta is approaching 0. Now you guys might start thinking that, sir, you are probably out of your mind. Correct? Because just if I look at this one, if I am trying to prove that this is equal to 1, tell me who all will agree that this is doable or not. Does it seem to be right in the first place? I am trying to prove this. Chris, what do you think? Does it seem right or not?
It doesn't seem right, but I think it is doable.
It is doable. Ananya, how about you guys?
I don't think it's right either.
Okay, that's good. That is when you guys start taking a teacher head on. That you are wasting your time and my time proving something that doesn't seem to be right. Yeah? And be brave to do so, okay? I'll give you guys a prize when you start doing that. I want my kids to take me head on. Mathematics. Right? I'm not as strong as you guys, I'm getting older. But here, this is what we'll try to prove. So this is the task we have at hand, that sine of theta by theta is equal to 1. We are trying to prove that. And here also we will use the squeeze theorem. We will eventually end up using the squeeze theorem. Okay? But that was just a clue. My goal is, or our goal rather, is to prove this. If you guys want to continue with me in the class, right? That okay, if the teacher is able to prove this, that means if he is able to prove it, which it doesn't seem to be right, then this teacher is worth spending time with, otherwise there is a problem. Let's look at it. Okay? So we'll start with a circle first. Let me try drawing a circle. And I will call this as a unit circle, meaning this guy has a radius of 1. Okay? And I am picking a point here on the perimeter such that this angle is theta. Okay so far? I've just drawn a circle with a radius, I mean it's a unit circle, so my radius is 1. And I picked up a point T so that my angle is theta. I'm going slow so that you have to digest this, okay? We are trying to prove something which is very uncommon. Yeah? Everybody okay? Nanya, Vilansi? Yeah? Okay. Now, I am dropping a perpendicular from here to here. Let's say this is origin O, I'll say this is Q. Now let's find out the length of this side, PQ. How much will be the length of this side? This is the vertical distance, this is y coordinate, right, or the vertical distance. This is unit circle, so this is 1. This is also 1. So, this length PQ by 1 will be equal to sine of theta. Okay? I am going to the assumption that I am still in the first quadrant because I am talking about theta approaching 0, so I am not thinking over, I am not going overboard thinking about second, third or fourth quadrant, okay? I am looking at first quadrant right now. So PQ over 1 is sine of theta, or we can say this length PQ is equal to sine of theta. Is everybody okay so far? Okay. Now, let me connect this point with this corner here, PQ. I'll say this is R. Okay. So I'll have to use different color coding a little bit so that it starts making a little bit sense, or it becomes more visible to you guys. So this is point P, reciprocal angle theta. I connected that point with the x-axis here, so that this point is R. We found this length. Okay. So if I have to find out if I have to find out the area of this triangle, OPR, triangle OPR, how much that would be? Half into base into height. Let me shade that in a color so that you guys can visibly see it. I'm looking at this yellow triangle, okay? Area of this yellow triangle will be what? Half into base into height. So half into base, what is my base? 1 because it's a unit circle, into height. That is this one, which we found as sine of theta. So my area of the triangle is OPR is sine theta by 2. Okay? Okay. Alright. So now let's look at let's add the green color to it. Meaning, if I have to find out the area of this, what is this one called? Yellow plus green, what will that be called? Sector? Yeah? If you have to find out the area of this sector OPR, how much that would be? Area of sector, area of, is it called sector or it's called segment? It's called sector, right? Yeah? If I have a circle like this and I pick two points in the perimeter, this whole area is called what? Sector, right? Not segment. Segment is the a sliced portion here, right? Okay. So, okay, whatever it is called, let's say this sector. Okay. Area of this sector will be how much? This is theta out of 360, right? So it will be theta over 360 times area of the whole circle, which is pi r square. Okay? Or if you think of this in radian, so it is theta over 2 pi into pi r square and my radius is 1, so 1 square will be 1. So this became, area of this sector became how much? Theta times pi over 2 pi, that is theta over 2. Correct? Are you guys following me so far? So, okay, let me state my story one more time. So we looked at, we picked up a point on the unit circle P and dropped a perpendicular from there onto the x-axis. We are trying to find out the length of this, or the height of this triangle basically. We are trying to find out the distance P to Q. And just going by the shortcut law, this is my angle theta, this is the opposite side by hypotenuse. So sine of theta is PQ by 1. That means PQ is equal to sine of theta. So we found this length as, or this distance is
Theta over pi, not theta over 2. Because 2 pi basically.
I'll come to that, okay? So I'm just teaching my story from beginning. So we found this length as sine of theta. So then we connected this point with the edge of the or this point R, which is on the x-axis, and we are trying to find out the area of this triangle OPR. Area of a triangle is half into base into height, so half into base is 1 because the unit circle, the radius, times height is sine of theta. So we found half into base is 1 into sine of theta. So this area of the yellow triangle we found as sine theta over 2. Now we are trying to find out the area of this sector, meaning the yellow and the green portion both. Now I'm coming here. So Vedansi, I'm ready to answer your question. Okay. What will be area of a sector? The angle that it makes, this divided by the angle the whole circle makes, which is 360 degree or 2 pi, times the area of the circle, pi r square. So I have a 2 pi here in radian as a denominator equal to 360 degree, and I have pi into r square the numerator. Would I not knock out these 2 pi's? One more time. Okay, it's okay. So look at this. I'll do it from beginning.
When we do maths in school, sometimes we don't usually do that too. When I normally do it, you take out, because 2 pi is basically pi plus pi, and then it's just rewritten as 2 pi. So that just means there is 1 pi left.
So I will not go that far. I'm just trying to find out this sector, area of this sector. Okay, it's a slice of a larger pizza. Okay, how much is the area or how big is the slice? This is making angle theta against the total angle the circle makes. Correct? Which is in radian 2 pi. Yeah. We just found the ratio of the angle against the full angle of the circle. Correct? So this guy's area will be a multiple of this times area of the entire circle. How much is that? Pi r square. Pi into r square. How much is my r? 1. So 1 square is 1. So we found this as theta times pi divided by 2 pi. Vedansi is still not convinced, and I will not leave it also till I force us to be convinced. It's a simple calculation, okay? This is, I'm trying to find out the area of this one. And how big is the area is a function of what is the size of the angle compared to the larger circle's angle. My circle's full angle is 360 degree. Let's say if this theta is covering half of it, the area will be pi divided by 2 pi, which will be half of the whole area. Since I'm talking about this angle, so I don't know how much is the value of theta, so I'm saying theta over 360. If this makes complete 360 degree angle, it will be 2 pi by 2 pi times pi r square. It is theta by 2 pi into pi r square. That gave me the value of this area equal to these 2 pi I will knock off. It becomes theta over 2. Little bit more convinced? Yeah? Ananya, Chris, are you guys okay? Yeah? Okay. So we found area of this triangle as sin theta over 2, area of this sector as theta over 2. Now let's continue with this journey and extend this point, this line, so that when I just stretch this line, okay, to a point, so that when I draw a perpendicular line from here, it intersects this one. Let's say this is S. So now let me use a little different color to make it visible for you guys. So I have done nothing but extended this red part. Okay? I took this radius OP, which was making this angle theta, extended that, and then from here I just created a perpendicular line on this point, and it met at S. So now I have a triangle, a rectangle, OSR. Yeah. If I have to find out the area of this triangle, we certainly know the base and we want to find out the height. How much is this height? Let's find out this height first. Again, we'll use SOHCAHTOA. So this is base. If we find out the tangent of any angle, base by height, right? We know the base and we are trying to find out this height. So that's why we are using the trig ratio tangent. So tangent of this theta will be equal to opposite side, which is SR, divided by adjacent side, which is 1. So SR, this whole height is equal to tangent of theta. So now we are ready to find out the area of this triangle OSR, and that will be half into base, which is 1, into height, which is tangent of theta. Okay? Or you can say the rectangle's area is tangent theta by 2. Okay? So far you guys okay? Want to take a sip of water, 2 times extra to digest this. So we have done nothing fancy here. We just took a unit circle. We picked a point on the perimeter of the unit circle, which is making angle of theta, and from there we dropped a perpendicular onto the x-axis to find out this height, and that we found as sine of theta. Then from this point we connected the end of this at the point of the perimeter, which is crossing the x-axis. So that made this triangle in the yellow color, and we found the area of this triangle is half into base into height. By base is always 1 because it is unit circle, radius of the unit circle, into height. This we found as sin theta. So we found that the yellow triangle has an area of sin theta by 2. Then we took this sector. For this sector we are trying to find out the area, and that goes by theta over 2 pi times area of this circle, which turned out to be theta over 2 pi into pi r square, and eventually that became theta over 2. Now we extended this OP such that to a point from where this is perpendicular to the end of this, this point R, and that became a triangle OSR, and we tried to find out the area. To find out the area of the triangle we need base and height. Base is known, height is what we are trying to find out, and we tried relating that with the angle theta. So this height came as tangent of theta. So this triangle's area is tan theta over 2. Now there are three things that we have. If you look at this guy, this one we found as tan theta over 2. So I am trying to create some real estate here. This yellow triangle's area is less than the sector's area is less than the larger triangle's area. You guys agree? So if I start visualizing this as three functions, I will say this yellow triangle, I am putting that as a function. There is a function that is drawing this triangle for me. Again, I am trying to relate that to the Squeeze theorem. Okay? Yellow triangle's area is how much? Yellow triangle's area is OPR. This is sin theta over 2. Is less than equal to this sector's area, correct? So this sector's area is bigger than the triangle's area. Sin theta by 2, which is the area of the yellow triangle, is less than equal to this sector's area, which turned out to be theta over 2. And that is less than the larger triangle's area, which turned out to be tan theta over 2. Yeah? We are somewhat getting closer to relating that with the Squeeze theorem. We are actually we are in a situation where we have the Squeeze theorem now. 2 is a common denominator, I will just knock it off. Sin theta is less than equal to theta is less than equal to tan of theta. The common denominator I have knocked off. Yeah? Ananya, Chris, are you guys with me so far? Now, I want to divide everybody by sin of theta. So, sin theta over sin theta is less than equal to theta over sin theta is less than equal to tan theta is nothing but sin theta by cos theta, and I am dividing that by sin theta. So now the fun time has begun. This gave you a value of 1. This is theta over sin theta, and this one became this. So this function became 1 over what? Sorry. 1 is less than equal to theta by sin of theta is less than equal to 1 by cos theta or sec theta, whatever you want to call it. But what was our goal? Since beginning we were trying to prove this. Sin theta by theta equal to 1. Meaning sin theta by theta. Sin theta has to be my numerator and theta has to be my denominator. So I want to flip the game. I want to bring sin theta to the numerator and theta to the denominator. So all my signs will change. Okay? Greater than will become less than will become greater than. So this became like this. 1 is greater than or equal to sin of theta. Sin theta by theta is greater than or equal to it will be reverse of this. So it will be cos theta again. Yeah? Are you guys okay so far? Now we are trying to find out the limit. See, we have to find out the limit of sin theta by theta when theta is approaching 0. Okay? We have a perfect spot to use the Squeeze theorem. Now, limit of 1 when theta is approaching 0 is greater than or equal to limit of sin theta by theta when theta is approaching 0 is greater than or equal to limit of cos theta when theta is approaching 0. First of all, this function limit of 1 when theta is approaching 0 says go to hell. sorry for the wrong word. It says limit. You don't have to worry about the limit part, okay? It's 1. Limit of cos of theta when theta is approaching 0. We know that cos 0 is 1. So when we are looking at the limit of cos theta when theta is approaching 0, limit of cos theta when theta is approaching 0 is anyways 1. Yeah? Because cos 0 is 1. We are in a perfect spot where this function and this function, which is outlining the boundary for this function or squeezing this function, both have the value of 1 for theta approaching 0. This guy has no choice, but this will be equal to 1 only, because both the sides that are squeezing you, both the functions that are defining a boundary, both have the value for x theta equal to theta approaching 0 as 1. So you don't have a choice. So even if this looked like one of the most unrealistic function limit, we could use the limit, Squeeze theorem or the Sandwich theorem to find the limit, which would have been a scenario of perfect give up for us, because to normal eyes, right, basic understanding of things, I would say that when theta is approaching 0, my denominator is becoming 0. It's a perfect undefined state. Yeah? But we could prove something against all odds. Did that make sense? If you look at this, this is nothing but a journey. We related that with unit circle theorem, because we just looked at the visual side of it. We took a unit circle, we picked a point where it's making angle theta, because I mean anything with that you are almost, I mean when we are almost about to wrap up, okay? I'll be wrapping up in a minute or so. So remember this bit, okay? Join at 8:15. This is the time for the calculus class, okay? So that way you'll be able to do arm wrestling with me, not a physical one, the mathematical one. Okay? So we looked at unit circle, we picked a point where it's making theta and theta, then we just defined. From this point, this is one triangle. Let me add a little bit to it so that I get another thing to compare, and then extend this further so that it becomes a right angle triangle. So this right angle triangle's area is more than this sector's area, and this sector's area is more than this triangle's area, and we could draw a correlation there. So that is how we went ahead and we were able to successfully prove that limit of sine of theta divided by theta where theta is approaching 0 is 1. Yeah? Alright, so that brings us to the end of the class. There was one more topic that I had chosen, okay? And I'm planning not to cover that because that is all about exploring types of discontinuities. And you guys already have seen the 3 flavors of discontinuities, okay? So I'll be wasting your time if I again talk about that. This is one function graph. Let's say the graph becomes discontinued here. Limit exists, this is the discontinued option. Second scenario is you have a function which graphs like this. There is a discontinuity and the limit does not exist. There is a continuity, limit exists. And the third scenario we saw was Vedant's favorite one, asymptote. I mean that's my asymptote, that is my favorite topic as well, asymptote, right? I mean where your function becomes out of bound. Okay, let's say this becomes out of bound. So literally there are three scenarios that we talk about. Limit exists but function becomes discontinued. Limit does not exist because at one point there is a break, and then some scenario where the function goes out of bound. So this is exactly what was there for with respect to exploring limits. That's why I am not covering that in detail. This has covered two topics within the same unit first. The first unit itself is so extensive. We have 13 chapters inside it. So we have covered 8 or 9 of them now. We have 4 more chapters to cover. 2 more classes will be done in the first unit, and that is when we'll start marching much closer towards the other interesting aspects of calculus. Yep. This is still calculus. I'm not denying this. This is part of syllabus. Okay. You will get some questions on this one too. Alright. So with that being said, we have come to the end of the class. Any questions? No questions. Already tired. How about Chris? Okay. How about Ananya? Okay. I mean, did that make sense? I mean, whatever I don't do it for myself. So as long as I'm making sense to you guys, I'm good. Okay? Yeah. Alright, so have fun then. Take care.